Welcome students in this beautiful session which is a current electricity. Today we will go through the topic Wheatstone Bridge. Let us see the topic. Wheatstone Bridge. Wheatstone Bridge is used to find the unknown resistance in a given network. Now let us see what is a Wheatstone network. Principle. Current does not flow between equipotential points. Wheatstone networks consist of four resistors R1, R2, R3 and R4 which are connected to form a quadrilateral. A source of EMF is connected between two diagonals opposite at a point as shown in this diagram. A sensitive galvanometer is connected between other two diagonally opposite points. Due to the source E, current starts flowing through all the resistors and all the branches. At the junction A, I split into the two components, that is I1 and I2. At a junction B, some paths of a current I1 flows through galvanometer. Let us consider this current as IG. At the junction D, I2 and IG meets and flow together through R4. At junction C, current I1 minus IG and current I2 plus IG meets and flow together as I. So current will not flow in the branch of a BD of the network. In the branch BD of the network and only VP is equals to VD. When there is a common potential or we can say equipotential, so that times IG is equals to 0. This happens to be true only and only if when R1 by R2 is equals to R3 by R2. This is known as balanced condition of a Wheatstone network. So let us prove that. Apply KVL on the loop ABDA. This comes minus I1. This will be, we are just moving in the same direction, so minus I1 R1. Then plus I2 R3 as we are moving. This is the opposite direction of the current. So this will be, I'm taking the positive, is equals to 0. Next, we can write up as a I1 R1 is equals to I2 R3. Applying KVL in the another loop which is a B, C, D, B. So, in the same direction again, minus I1 R2, opposite direction, I2 R4 is equals to 0. From equation first and second, we can say that R1 by R2 is equals to R3 by R4. So, balancing condition of a Wheatstone network can be obtained by using Ohm's law as well. Let VA, VB, VC and VD be the potential at the point ABCD. VB is equals to VD and minus VB is equals to minus VD. So VA minus VB is equals to VA minus VD. That is I1 R1 minus is equals to I2 R3. This is the first. VB is equals to VD. So VB minus VC is equals to VD minus VC. Hence I1 R2 is equals to I2 I4. So from the equation 1 and from the equation 2, we can write up as R1 by R2 is equals to R3 by R4. Let's start with some questions so that we just explain the things which we understood or not the earlier. Wheatstone bridge can be used to compare to unknown resistance, to measure small strain produces in the hard metals. Next we have as the working principle of a meter bridge or the above. So the correct answer for this question is all the above. Next question we have Wheatstone bridge is the most sensitive when the arm ratio is equals to 1, less than 1, more than 1, 0. The correct answer for this question is equals to 1. That time, Wheatstone bridge is the most sensitive bridge. Meter bridge. This is a device, a practical application of a Wheatstone bridge. Use first measuring to unknown resistance and second verify the resistance or law of resistance. Let's have a look at the construction of a meter bridge. So this is a C1 and C2 strips. This is C3 strips. So metal strips are used for low resistance. Wire AC is made up of a nichrome, magnet or constantin. And due to higher specific resistance, that is a high resistance value. With the attached meter scale, so rheostat is used to reduce the current in the network. Jockey is free to move on the wire AC. The key K is closed and the current allowed to flow through the circuit. This is a complete diagram of that. So apply Wheatstone bridge principle over there. X by R is equals to resistance of the wire AD and the resistance of the wire DC. That means sigma is equals to R by L. So R is equals to sigma L. We can just put this value over there and get the value of X by R, which is Lx by 100 minus Lx. So X is equals to R times Lx divided by 100 minus Lx. So knowing the value of R, X can be calculated easily. Now let's quickly revise the topics which we earlier studied by the help of our MCQ questions. In a meter bridge experiment, when the resistance in the gap are interchanged, the balance point did not shift at all. The ratio of resistance must be very large, very small, equals to the unity 0. The correct answer is equals to the unity. So this is all for today's session. Hope you like the session. So till that, revise this topic and take care of yourself. Thank you for watching this video.